we saw how a star formed. We took a collection of gas and it was squeezed together by gravity and it was spinning. What we focused on was the center where the gas got pushed so hard and there was so much gravity that fusion started and we had a star. But there was a lot of material that was spinning around that star, and some of that material that is spinning around doesn't end up in the star, but is the material that makes the planets. And so all the planets are going in the same direction as that spin, just like us, and all of the planets are spinning in the same direction unless something hits them. And so that initial cloud of dust creates the star and has the potential to create all of the planets around a star. So the cloud of gas that comes and creates the star in the center leaves material around the edges. Closer to the star would be the rocky material to create rocky planets, and the things that are on the outside are gas-like material, and then you can get the gas planets. And so we believe that this is how stars form, and if it is a messy process and not all of that material goes into the star, then there should be lots of stars with lots of planets roaming around stars that are in the night sky. Now, if a planet was around another star, we're going to call them extrasolar planets. And so when we look up and think about how things are formed, there is a high probability that every star that we see most likely has planets that are surrounding that star. Now, that doesn't mean that every planet in a solar system might be ones that life could form on. Just like our solar system, most of the planets didn't have conditions in which life could form, but there could be planets out there. And so we are beginning to actually do experiments and to actually identify extrasolar planets. There are two ways to find a planet around a star. One is called the wobble method, and the other is going to look at how the star's light, if we look at it for a long period of time, may dim a little bit when a planet gets between the star and Earth. So we're going to find planets in two different ways, and we'll describe both of those. The wobble effect is that planet moving around the star, and the star wobbles as it's being influenced. The problem with wobble planets usually is this: they're very, very large planets, more like the gas giants. Now, if we're looking for planets out in the universe, we really don't want to find a Jupiter-like planet. We want to find a planet like Earth, possibly a place where we could go. And so the wobble method has identified planets, but not the right kinds. What we want to find are planets in what is called the Goldilocks zone, in which it's not too close and it's not too far away from the star. It's right in the perfect spot, so that there's a rocky surface with water that is liquid, and it has all the combinations of conditions that look like what we have on Earth. If you have planets that meet those criteria, then there is a possibility that life might evolve there, and or it may be a planet that we could reach at some point in the future and colonize. And so what we're looking at is, or trying to find, is Goldilocks planets. Now, another way that we look at in the night sky to find planets actually can identify these kind. The Kepler space mission put a telescope in orbit looking for light, and that telescope wasn't even in the orbit of Earth. It was actually in the orbit of the Sun. We sent it very far away from the Earth, and unfortunately it has ran its lifetime. It used its full power source, but we did extract a lot of data from that mission. We are still analyzing the data that was sent back. Okay. What actually happens is, as the planet crosses the sun, the amount of brightness goes down just a little bit. And so what they're calling this method is the transit, as it goes across the star, and the amount of light that is blocked, which is a very small fraction, you can observe planets around a star. We have identified now a number of stars. Over 2,000 planets have been officially classified. Many of the stars have a single planet around them, but there are examples where there are up to 8 different planets around a star, a couple of systems. That number will increase as we go through the Kepler data because it hasn't been all analyzed yet. And there's just tons and tons of data.